Hi Year 3, it's Miss Sabbath here. I thought we could do a bit of a math lesson and I thought we could focus on finding non-unit fractions of amounts. So that is our learning question today. And by the end of this little lesson, we are going to be able to recognise the difference between unit and non-unit fractions, find non-unit fractions using jottings to prove my answers, and then possibly solving two-step problems involving non-unit fractions. So, a quick recap. I wonder if you can remember what a unit fraction is and what a non-unit fraction is. Just have a bit of a think, maybe jot down some of your ideas from what you can remember. So, a non-unit fraction is a fraction where the numerator, the number on the top half of the fraction, is greater than 1, which means that a unit fraction has a numerator of 1. So here is an example of a unit fraction. What is that fraction? It is 1/3. It is a unit fraction because it has 1 as the numerator. Any non-unit fraction is any fraction where the numerator is greater than 1. So we could have 2/6, for example. We could have 2/5, for example. It could be 4/5. It could be 3/6. All of the numerators are greater than 1, which means they are called non-unit fractions. So knowing that, I want you to just have a think, how are these fractions here that are shaded the same? Well, let's identify first what fraction is shaded. So here we've got this rectangle split into or shaded into 1, 2, 3 equal parts. So my denominator is 3. And it has 2 shaded orange. So the numerator is 2. So shaded there are 2/3. If we look at this second rectangle, it is shaded into 1, 2, 3, 4 equal parts, and the denominator is 4. And how many are shaded? There are 3 shaded. So of that rectangle, there are 3/4 shaded orange. Now, what is the same about these fractions? Can you identify something? So what is the same? The similarity is that they are both non-unit fractions because the numerator here and here is greater than 1. So we're going to use our non-unit fractions today and we're going to use them to find fractions of amounts, and we're going to use our times table knowledge and some jottings to help us. So here's an example of finding non-unit fractions of an amount. So we've got 2/5 of 10. So we're imagining that we have got 10 objects and we want to find 2/5 of them. So 10 is my total amount of objects. Let's say that they are going to be tennis balls. So we've got 10 tennis balls and we are sharing them into 5 equal groups, and the reason I know that is because my denominator is 5. So below I have shared 10 into 5 equal groups. Now, knowing my 5 times table, if I counted in my 5s, 5, 10, how many lots of 5 make 10? There are 2 lots of 5 make 10. So here I would put 2 and I would repeat that all along. Another way I could show that is I could have 5 equal groups, 1, 2, 3, 4, 5, and I could share my 10 tennis balls equally between these 5 equal groups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in each equal group there are 2 tennis balls, which is what we have here, and we can just double check that by adding them together. 2, 4, 6, 8, 10. Now, my question to you was, can you find 2/5 of 10? Well, if this is 1/5 here, let's just jot that below so that we remember, that is 1/5 here, then this must be 2/5. So we have got our 1/5 there, 2/5, 3/5, 4/5, and 5/5 or a whole. So 1/5 of 10 is 2. 2/5 of 10 then must be 2. Add 2 makes 4. And we can double check that over here with our jottings. So we've used our times table knowledge here. Now let's check with our jottings. Here's 1/5. There are 2 tennis balls. Here are 2/5, and there are 1, 2, 3, 4 tennis balls. So we were correct. I wonder if you could have a go now at finding 3/6 of 18 and 4/5 of 25. Now I've drawn a diagram below where you can jot down some of maybe your times tables to help you, or maybe you want to draw the rectangles like I did as well to check, just as another way for you to identify the answers. So I've just filled in the answers and filled in my working out. Hopefully this is what you got. So 3/6 of 18 is 9. 4/5 of 25 is 20, because 1/5 is 5. So 4/5, 5, 10, 15, 20. 4/5 of 25 is 20. I wonder if you could apply it now. So this is a 2-step problem. So Susie ate 2/4 of 16. So we need to find 2/4 of 16. But then Dina ate half of what was left. So you need to first find 2/4 of 16 and find out how much Susie ate. And then whatever was left, Dina ate half of that. So can you identify how many sweets were left at the end? So I've jotted down my working out. So Susie ate 2/4 of 16. I figured out 1/4 first, which was 4. So 2/4 is 8. So that's how many she ate. And we had 16 in total. So we wanted to find out what Dina ate of what was left. So 16 in total. Subtract the 8 that Susie had. Left me with 8. So Dina ate half of those 8. Half of 8, showing 8 into 2 equal groups, was 4. So Dina ate 4 sweets. But my question says, how many sweets were left? So if Susie ate 8 of them and Dina ate 4 of them, then altogether they ate 12 sweets, but there were 16 in total. How many were left? Then we would have 16 subtract the 12 that the girls ate, and that would leave us with 4 sweets left. Maybe you could have a go at writing one of your own problems like that. Or maybe you could change the fractions. Maybe Susie ate 3/4 of the 16 sweets, and see how your answers change. Have fun.